So in the second example, I'm looking at Chapter 20, Problem 20.9, and it's similar to the previous one that we did, except there's a few differences here. So what they're saying here is that there's a one sample t statistic from a sample size of n equals 5 observations for a two-sided test of the null hypothesis being that the population mean is 50, and the alternative hypothesis being that the mean does not equal 50. So kind of like the whole example of the world is flat versus the world is round. So is the world flat? Well, yeah. If mu is equal to 50, then the world is flat. If it's not equal to 50, then it's round. But what this implies is, if I draw a normal curve here, what this implies is that we're looking at the tails of this normal curve, and we're saying that it either equals 50, so it's within this range, or it doesn't equal 50, so it's either above or it's below. So it's a two-tailed analysis in this case because of the fact that we have this not equal sign in here. So question A asks us, what are the degrees of freedom for t? So degrees of freedom is equal to the number of observations, so n minus 1, which is, in this case, 5 minus 1, which is 4. So we have 4 degrees of freedom in this example. So part A is done. So now it's asking us to locate the two critical values t star from the table that bracket t. So what are the two-sided p-values for these two entries? So there is opportunity here. We need to add our t-table, or we need to look at the t-table, and I just put the t-table up here. So we have a t-value that we're going to be looking up, which is 2.5. They gave us that. Now remember, the t-value, just as a refresher, the t-value is equal to the mean, the sample mean, minus the null hypothesis mean over the standard deviation of the sample, because we don't know the population standard deviation, divided by the square root of the number of samples, just so you kind of know where that t is coming from. So we are given t is equal to 2.50. So we're going to go to our t-table. In the t-table, we need to know two things. We need to know the degree of freedom, which is 4. So we're going to go down to this 4 row here for the degrees of freedom. And now we're going to go over until we can find something that's close to the 2.50. So if I go over here, 0.7, no, 0.9, no, 1.19, no, 1.5, 2.1, we're getting closer. We want 2.5. So 2.1 is there, and the next number there is 2.7. So we know now that it's somewhere between those two numbers there, 2.1 and 2.7. So we know it's somewhere there. Now, we're looking at a two-sided tail here. So again, we're looking at the cases where it's either greater than 50 or less than 50, but it's not equal to 50. So in this case, we're looking at the two-sided p row down here on the bottom. So if I follow these numbers down, you will see that p is going to be between 0.1 and 0.5, or 10% and 5%. So p is going to be between 0.1 and 0.5, and it's going to be between those. So it's going to be greater than 0.1 or less than 0.1 and greater than 0.5. So this is the range of the two-sided p. So the question then becomes, in part C, is is the value statistic t equals 2.5 statistically significant, at the 10% level? So C is asking at the 10% level, and again at the 5% level, and at the 1% level. So let's look at the 10% level first. So that we can translate into 0.10. So at the 10% level, we can say that P is less than 0.1. Because remember, the 0.1 in our original range here is not inclusive. So it's less than, but it's not less than equal. So P is less than 0.1. So that means that this test is significant. Now the second part of this question is asking at the 5% level. So 5% we can translate to 0.05. And now P is greater than 0.05 in this case. It's between 0.1 and 0.05. So P is actually greater than 0.05, which means that this is not significant because it's greater than that value. So it's not significant. And now if we look at the 1%, this translates to 0.01. Well, now we know if it's not significant at 5%, we know it's probably not significant at 0.1 or 1%. So this is also not significant. And then the last piece of this is if we knew the exact two-sided p-value here, could we calculate it? So the answer is yes, we can calculate it by using the tdist function. So in any software, spreadsheet application, Excel or Google Sheets, we can type in equals tdist, and then it will ask us for our t-value, which would be 2.50 or 2.5, our degrees of freedom, which would be 4 in this case, and then the number of tails, which would be 2. And this should give us a number that should be close to P is equal to 0.0668. And that should be our p-value. So that's the exact value. So if you think about that, that's actually between 0.1 and 0.05, just as we had mentioned in our estimate up here using the tables.